sound effects. Welcome back, everybody. So let's talk about moving forward. Where are we going next? Well, today what we're going to do is section 7-8. And you're thinking, wait a second, I thought we just took our chapter 7 quiz, right? Yes. But what we're going to do right today is kind of review everything that we talked about on that quiz and talk about what the next step would be after we had factored just our one single pieces. It'll make sense in a second, I promise. But we are not going to have a full chapter 7 test. Okay? We are not going to have a full chapter 7 test. Everything that I covered today, I assessed yesterday on yesterday's quiz. Okay? Everything that we will cover today, I've already assessed on yesterday's quiz. Get out of here.
I just wanted to see where Izzy was sitting.
Get.
I'm right here. I'm sorry.
Everybody, this is Mr. Parker.
Hi, guys.
You're on video. You're on recording. So just so you know.
I don't care.
So everything that we will cover today, I have already assessed yesterday. So that's why we're not going to do. It would be redundant to do another quiz after that, and I don't really feel the need to do that. So we're going to do today's lesson, and I'm going to talk about how it will impact what you do, the kind of questions that you might see on the end of course test as well. Then tomorrow we're going to get into chapter 8, and then we will get moving into something completely different. Okay? Yeah, question?
What does redundant mean?
Means it would happen over again.
You're dumb if you gave
kind of just things that would repeat itself are redundant things. Redundant tendencies.
aggravating.
All right, so this is what we're going to do today. We're going to talk about section 7-8 today, and then again tomorrow we will get into chapter 8, something completely different. We'll start quadratics tomorrow.
What is that?
Oh, just wait.
That's graph, right?
Yeah, we'll be doing a lot of graphing coming up in chapter 8.
That's great.
Just keeps
Good
getting
stuff.
worse.
We'll take it slow. We'll be all right. We'll be okay.
Oh my goodness, we never take it slow.
We do for 10 seconds, and then he goes and he speed writes, and nobody can keep up with him anymore.
I don't
You
speed.
Yes, you do.
I
Yes, you do.
You're covering
He's like a slow pace.
You stand right in front of it and speed write it, and then trick all of us be able to see it.
Alright, guys, next question.
I just go and I look at the computer.
All right, here
Never
we go.
seen it for that.
So, I gotta give one.
He's never sat in front of that computer, so I can just look at that.
Well, you could write and have that time to homework. I guess it's cool.
He's like writing in another language.
The problem with you, Brennan, is you don't ever try on your homework. So it is like another language. All right, so section 7-8. That's what we're looking at today, section 7-8. Now, I leave a big blank spot for you up at the very top for this thing called the factoring flowchart. Now, I am going to review everything that we've covered within chapter 7 so far with this flowchart. Let's think about it the very first time we started factoring. What did we do? What was our first thing that we talked about? Like those first couple questions on your quiz. What was the only thing you had to do there? Factor by GCF, right? That was the very first thing that I asked you to do, was to factor by GCF. Okay, and again, I'd like you to draw this out in that big space that you have. You right? You need to go back. So we factored by GCF at the very beginning. And what does that mean? That means we factor something out. We figure out what is all divisible by those things, and we factor it out. We take it out, right? And then we said, well, let's break apart factoring and define it by the number of terms that you have. And we said you could either factor something by 2 terms, and I'll explain what these are in a second. We factored by 3 terms, or we factored by 4 terms. And we actually went kind of backward in order. We started here. We started with 4 terms. Can anybody remind me how to factor something with 4 terms? Grouping. Right. That was the grouping method. The only way to factor something with 4 terms is the grouping method. And again, you should be copying this down. Is factoring by grouping. That's the only way we know how to factor something with 4 terms. It's the factoring by grouping method. Now, what does that look like? That would have been like something like 2x to the third plus x squared plus 2x plus 1, something like that. And we said, okay, you would underline the first two and the last two. That's the grouping method. Group them up and take a GCF out of both of them, and you might find a common binomial. If you don't find a common binomial, then it was prime. That's the 4 terms, right? That's the only way we know how to factor something with 4 terms, the grouping method. Now, we talked about 2 different ways to factor a trinomial, a 3-term polynomial. What were the 2 different things that I was talking about?
Whenever like there's a number in front of the x.
Right. The easy type versus hard type, right? We distinguish them in 2 different ways. Oops, it's going to annoy me if that's not in blue. We talked about them as the easy type or the hard type, right? We talked about them as the easy type problems or the hard type problems. And we said, well, if there's a number out front, then that was the hard type. So something like if I had, 2x squared plus 10x plus 7, that would be better. No, whatever. That doesn't factor, but it doesn't matter. What am I getting at here? The fact that there is a 2 out front. Those are hard to make up on the spot. Okay. The fact that there is a 2 out front makes that a hard type, and then I would have to do 2 times 7 to find the factors of 7. That would give 10, but whatever. You get the idea. The fact that there was a 2 out front. Now, the easy type problems, those are the ones where it was like, okay, x squared plus 7x plus 10. Those are easy to make up. Factors of 10 that have to get to 7. 5 and 2. That's why it's the easy type, because those sets of factors should be right there. Okay? And how do we know it's the easy type again? That there's no number out front. There's nothing out in front of the x squared. Okay. All right, and then we talked about the factoring by 2 terms. And there was one very special case that you could factor something with 2 terms. And the only way you could factor something with 2 terms is if it was called a difference of squares. This is the only way something with 2 terms could be factorable. Difference of squares. And what did that look like? That was something where it was the x squared minus 64, right? Where they're both perfect squares and there's a minus sign in between, and I can make a plus and a minus, right? Those are those last couple questions of the quiz. Questions about that flow chart? I mean, doesn't that summarize like everything that we talked about over the past couple of weeks, I guess? Yeah. So here's what we're going to do today. I'm going to say to you, well, from beginning to end, every time on your quiz yesterday, I only had to just factor the trinomial, or just factor it by GCF, or just factor it by grouping. But what if there were multiple layers onto it? What if you could factor out a GCF and then it would factor more? And what if you factored the trinomial and that binomial was maybe a difference of squares? See, what happens if you've got multiple layers to it? That's what we're going to talk about today. Have I assessed everything on this board? Did I assess everything on this board yesterday? Yeah. All we're doing today is kind of like putting it all together and like jumbling it all up and seeing if we can figure out what piece to do when. Now, I will say this. The first thing, the big thing at the top of that flow chart was GCF, right? That's the first thing that you should always try to look for. If you're going in order, the first thing that you should always try to look for is to factor a GCF. And remember that if you get to the end of your flow chart and nothing has happened, and I mean nothing, not even a GCF, that's when you can call it unfactorable or prime. So let's get started here. 10x squared plus 48x plus 32. I should always start to try to find a GCF first. Don't take 10 times 32, not yet. Because what can I divide out of all 3 of those terms? 2. Nothing bigger than that. Like, look at the smallest number there, 10. The only factors of 10 that I can divide out are 10, 2, and 5, right? Well, they don't divide by 10, and they don't divide by 5. So the only thing I could divide out of all of them evenly is 2. So let's divide that out. Okay, that leaves me with a 5x squared, a 24x, and a 16. Did I ask you to do that on yesterday's quiz? Yeah. Factored by GCF? Yeah. It was in that first couple questions.
Oh yeah, I asked you about that.
You get your sets.
No, I'm using my phone.
Oh, okay. Okay. So yeah, I asked you to factor by GCF yesterday. Now, take a look at my inside piece here. That 5x squared, 24x, and 16. If I kept going with my flow chart, how many terms does this have? 3 terms, right? Is this an easy type or a hard type? Hard type, because you see a number out front. So the new piece for today is saying, well now, let's keep going with that trinomial. What is 5 times 16? 5 times 16 is 80. So I'm going to say factors of 80 that add together to get 24. Factors of 80 that add to get to 24. What are they? 20 and 4. Switching colors all over the place. Now, what do we do with this 2 out front?
You just slide it down like the -1?
Exactly. We take this and go whoop, whoop, whoop. Just like we did with the -1. Acts the same way. And now we factor like we always have. 5x squared plus 20x plus 4x plus 16. Factor by grouping. We pull out a 5x, and we're left with an x plus 4. We pull out a 4, and we're left with an x plus 4. X plus 4 is our common binomial. 5x plus 4 is our leftovers.
You weren't supposed to do this on a test, right?
Correct. There were none of these on the test yesterday. I made it happen that there wasn't any of these. Yeah, you wouldn't even have known to look for it. So that is our final answer. So now do you see how we're going to be factoring out a GCF and then factoring more? That's what we're going to be looking at today.
So we've gotten like 8, 10, and 8 instead of 4, 5, 4.
Oh, if you had not factored out the GCF, you would have gotten a 2x plus 8, 5x plus 4.
Yeah.
Like distributed into 1 there. Yeah. Okay, let's keep it going. Let's take a look at the next one here. 8x to the 6th y squared minus 18x squared y squared. What's my GCF? Kenny?
2x squared.
Did you have a question?
No,
What was it? 2x squared y squared? Good. 2x squared y squared. 2x squared, well, where did that come from? Well, 18 and 8 both divide by 2, nothing more. They both have an x and y in common, and the smaller power on each one of them is 2. So let's divide that out. 2x squared y squared, 2x squared y squared. All right, so that means I've got a 4x to the 4th, and then a minus 9. That's it. Right, because the x squared, y squared canceled out. So I factored my GCF, right? Okay, keep going on the flow chart. Inside piece, does that have 2 terms, 3 terms, or 4 terms? Is that a difference of squares?
Yes.
Well, is 4x to the 4th a perfect square?
Yes.
Yes, because 4 is a perfect square and x to the 4th's got an even power. Is 9 a perfect square?
Yes.
Is it a minus sign?
Yes.
So now I can indeed say that this is a difference of squares, 1 minus 1 plus, and I square root. 4x to the 4th turns into a 2x squared. 9 turns into a 3. And that's where I can stop. Yes, sir.
So can you have your GCF on the outside and you just have 2x to the second minus 3 raised to the second?
No, because they're not 2 of them minus 3s.
Oh yeah.
One's a minus, one's a
They're
plus.
different squares.
My bad.
That will come up in a second, though.
Oh, okay.
Now, take a look at what I've got on my board here. You know what questions I've seen on the end of course test? They're questions that say, select all equivalent expressions. Select all equivalent expressions. And you know what I bet is one of the answers there? This. Is that technically an equivalent expression?
Yes.
Yes. Is it fully factored? No, but that's not what they asked. They said, is it an equivalent expression? You would have to check that box and say, yeah, 2x squared y squared times 4x squared minus 9 is an equivalent expression. Should you also select this box down here? Yeah, because that is also an equivalent expression as well. We see that all the time with these factoring problems. We see them so that there's the big starting value, and then each piece along the way is like factored one more step, and you kind of got to select all the pieces that would still be equivalent.
It seems like what we do in the state test is nothing like we ever learned during the
Well, we learn the basics during the year. I teach you the nitty-gritty stuff. What they ask you is a lot more of conceptual stuff. Like, did everybody take the quiz in here?
Yeah.
You know that bonus question that you had?
Yeah.
That was an actual test question.
What?
I didn't attempt it because
I
I
know.
was something else. But
I know that was an actual test question that they gave, and me and D-Lap were like, "You got to be kidding!" Like it was worded, and I'll show you what the answer would be later on once everybody's taking their quiz. But yeah, and you're gonna be like, "Oh, that was easy. Why did they ask it that way?" And I go, "I know."
I thought
I
it was
know.
something we never learned before. 'Cause
No, you learned it. You just had to figure out. Well, I'll talk about it.
what they were trying to say.
Let's take a look at this one. I've got. Well, that was on video. Whatever. 12b to the third plus 48b squared plus 48b. Nathan.
12B.
12b is my GCF. 12b. is my GCF. Now let's factor it out. That means we've got a b squared, a plus 4b, and then just a plus 4 sitting there on the end. You see that? We're factoring out that 12 and the b. Okay, keep going with the flow chart. I did my GCF. How many terms does this have on the inside? 3.
But it's the easy type.
But it's the easy type. So if I can factor it more, please pay attention. If I can factor it more, I should be looking at the last term and seeing what factors of 4 add to get to 4. 2 and 2. Okay, so that means I've got 12b. I can go straight to my answer because this is an easy type. Could I write this in a different way? No?
Yeah, just square.
Yeah, 12b and then b plus 2 squared. See, the test makers would have a bunch of different options to put on there as like the select all. Because this could have been a viable answer. That looks like a negative sign. This could have been a viable answer. And this could have been a viable answer as well. Right? Because technically, aren't these saying the same thing? As well as this? Nathan?
Can the state test hold you back if you didn't understand that?
They won't let you graduate until you have accumulated enough points on the state tests in total.
And
You can't get your diploma until you accumulate enough on the state test.
Are those state tests like hard to get the points?
You have many times to retake them if you need to.
You're fine, man.
That's why they don't give any tests your senior year either.
Oh, okay.
I will say this, I don't think that's ever happened that someone has not gotten the diploma from a
Okay.
state test.
Sure. Okay.
Joe,
Did you get
Two.
credit?
I want to talk to the video. Hi guys.
Alright.
It's Izzy. Welcome back to my YouTube channel.
No, why didn't you
If you're new here, hit that like
Because I
button and
was
hit those
gonna talk, like, we
notifications
never
to get my
learned
videos
this.
every
I'm so
day.
dumb.
Let's watch that.
We're missing
Yeah, I
that
should've wrote
class.
down randomly.
Yeah.
you talking to the video?
It's my video now.
It's not you hijacked the video. All right,
All right, then.
take a look at this one. Is there any GCF here?
Yes.
Yes, what is it?
X to the
X squared. See, there's not even any numbers in this one. No constants. So x squared gets pulled out, and we're left with an x squared and a minus 1.
We're just doing alphabetical math at this point.
Alphabetical algebra.
Yeah, well,
Right.
nice.
Algebra.
Wait, that's what it means?
All right. So now,
Algebra means like alphabetical.
actually, algebra. Okay. So now, history of math lesson. Algebra
It's not algebra.
You're getting way too
actually was created by this guy.
Algebra.
Algebra.
Algebra and alphabet.
Comes from Big Latin.
That was his
What?
last name.
How do you
Al-Khwarizmi.
That is not.
That was that guy's name, right? That was his last name.
That guy lives in the deepest forest.
Algorithm.
How do you pronounce that?
Oh, what?
History of mathematics. Yeah, I had to take 2 classes of this in college, so I do that. So this guy, I forget what his first name is. Al? No, it's not Al. It's probably like Muhammad or something like that. Yeah, because honestly, all of our math. Oh, this is all being recorded. I do. All of our math came from like the Middle East. Like back when the back when all of this stuff was being created, like the Roman Empire, the Grecian Empire, all of that stuff. Everything was either Latin or Greek. That's why a lot of our like the symbol pi comes from the Greek language. A lot of like Roman things, Greek things, Roman numerals, things like that. But the one of the big places to study was Alexandria, which was a city in Egypt, right? And he was studying at the Library of Alexandria, one of the ancient wonders of the world, right? And so, because we all know that.
Of course.
So this guy was studying at the Library of Alexandria. Like if you think about our number system, like why does this symbol mean this thing?
Yeah,
These are called like because in Roman numerals, this equals that. I equals 2. Right? I.
It's 2 lines.
Like a V equals 5
Every other
Yeah, but
country
like,
in Roman numerals, right? So these numbers are just the ones that we use. You want to know what those are called? Like these are called Roman numerals. Our numbers are actually called the Hindu Arabic numeral system.
Oh my gosh, I'm Arabic.
We're American.
Small world.
Yeah, but how do we go from a V to
Well-
a 5? That's what I don't understand.
Small world.
I know.
Roman numerals.
That's like actually back
back
in like Mesopotamian, they had this thing called cuneiform where it looked like this.
Yeah, and they would draw on
Like those, each one of those represented one thing.
Oh, that's what they carved in the cave.
yeah, we had
Yeah.
to write our name and
Like-
say it.
Yeah.
Like the cave.
And if they crossed, it meant certain things and whatever.
That's how they say it. They write it in the cave.
So
And we write their name.
there we go.
Okay. Don't cut this out. This
Thanks
is
for the
Leave this in. This is
yeah, I
amazing.
look forward to watching the videos when there's something funny.
All right, so take a look at that.
Actually,
Let's get back to this. Now, can I factor that even more?
Yes.
Yeah, because look, I've got 2 terms there. X squared and a minus 1. Difference of squares? Is x squared a perfect square?
Yeah.
Is that a minus sign?
Yes.
Is 1 a perfect square?
Yes.
So it's
Yes.
X plus 1 and minus 1.
Yeah. So now we can say x squared, x minus 1, x plus 1. Could I go more? No, because either of these, well, that's a plus sign, so that can't be factorable. That minus, well, is x a perfect square? No, because it's got an odd power. It's just a single x. It's not a perfect square. All right, let's keep it going. Flip over to the back, please. Let's take a look at this next one. What's my GCF here? Tommy?
3Q.
3q to the 4th. 3q to the 4th. Okay, now, let's divide it out. 9 divided by 3 is 3. q to the 6th over q to the 4th is a q squared. 30 divided by 3 is 10. Q to the 5th over q to the 4th is q. Plus 8.
Why can't you just do X?
Yeah, I know.
I know. Yeah.
Okay, so would you? Not that I did this. Well, I probably did, but if you didn't simplify, would you like mark off?
What do you mean?
Like if instead of doing 3q to the 4th, if you just did like
Just q to the 4th?
or 3, yeah. Like would you? Mark
It has to be fully factored down. Like either you factor now, or in the end it will come out to be something more factorable.
Oh.
So there's either two options: you can factor now or factor later. And I always say factor now.
Then you might forget.
It's Untitled.
Oh, okay.
So now let's keep going here. 3 times 8 is 24. See, I've got a trinomial here, and this is a hard type, so I have to do my 3 times 8. And we see 3 times 8 is 24. Factors of 24 that add to get to 10?
6 and 4.
6 and 4. See, I need to keep going. Henry, I really wish you would pay attention. You paying attention, Henry? So now let's arrow down this 3q to the 4th, because this is going to take us a couple of steps. So we have 3q squared plus 6q plus 4q plus 8. And now we factor by grouping. We pull out a 3q, and we're left with a q plus 2. We pull out a 4, and we're left with a q plus 2. All right, our common binomial, so now I can catch up with the 3q to the 4th. Our common binomial is the q plus 2, and our leftover pieces are the 3q plus 4.
You always write your Q's like that?
Yeah, because if there's no lines, they look like a 9.
You know, there's like,
Just do the little.
Is that
You can do
it?
the bottom.
It takes too long.
No.
All right, so take a look at that one. Can I keep going on either of those?
No.
No, because they're both plus signs, and they're like because they're binomials now, but they're plus signs, so they can't be factorable anymore. So that's my end result. Let's take a look at the next one. Go ahead and start factoring out your GCF of the next one. Yep. What's my GCF of the next one? Just 2, right? And when we factor that out, I get, I'm writing a Q. Oops. I get a x squared plus 9, or x to the 4th, x to the 4th plus 9. Okay, now, x to the 4th, is that a perfect square?
Yes.
Is 9 a perfect square?
Yes.
But is it a minus sign?
No.
So that means I'm done. The reason, and I knew somebody was going to say that, it's not prime. Because did we do something to it? So that's my answer. The common tendency is to say that since you couldn't finish out your flow chart, then you'd say it was prime. No. We did something to it. Didn't we factor it by GCF? Then that's my answer. Not prime. That's my answer.
My bad.
Okay, this is a doozy. This is a fun one. There's a lot of steps on this one.
Well, you gotta order them.
Okay, so right off the bat, do you see how this is misordered?
Yep.
Let's rewrite it. So my first step would say that this is a negative 20x to the 3rd minus 28x squared plus 5x plus 7. So right off the bat, I see that I've got to reorder it. Now, what's the next thing that I should do?
The negative?
Yeah, it leads with a negative. Let's also check to see if there's any other GCF.
Are you doing grouping right now?
Not yet. Because do you see how this big 4-term polynomial, the first term is negative? Is there anything I can divide all 4 terms by?
No.
Other than 1?
No.
No. So here's what we're going to do. We're going to take out a -1. And everything is going to be divided by -1. So that means we've got a positive 20x cubed, a positive 28x squared, a minus 5x, and a minus 7. See, we did that with trinomials, but we never did it with a 4 term. Still the same process, though. What do you think I'm going to do with this -1? Yeah, I'm going to bring it right down here. Now I factor by grouping on the inside. What's my GCF of my first 2 terms? 4x to the second. And that leaves us with a 5x plus 7. What's my GCF of my second 2 terms?
-1.
-1. It leads with a negative, so this I have to pull out a minus. And there's nothing in common between 5 and 7. So -1. And essentially all that does is just flip the signs on the inside, which is great. My common binomial is my 5x plus 7. My leftover pieces are the 4x squared minus 1.
You know how you like both the inside numbers are the same?
Yeah.
Before you do that, could you just do like only the first one?
Be careful with that.
Yeah.
You can kind of get a good hint at what it's going to be, but I would be careful because what if it ended up prime? You know? All right, now, does anybody see what I can do? Nick?
You can call the difference of squares.
The difference of squares. Very good. Look at that piece right there. 4x. Did we do an example just like this a second ago? 4x squared minus 1. That is a difference of squares. So I actually can take this one step further. 2x minus 1, 2x plus 1. This can get broken apart because it's a difference of squares. And that's where these can get really tricky, because there might be hidden pieces that you might not see. Always check for little difference of squares like that, or factoring out a GCF, or factoring out a negative. That one was tricky. We had to do several things. First, reorder it. Second, get rid of the -1. Third, factor it by grouping. And then fourth, recognize that there's a difference of squares in there as well in the end. Okay, take a look at our last one there. Is there any GCF?
No.
Other than 1, I guess I should say. Is there any GCF other than 1? Nope. 2, 3, and -1. Nope. So that must mean that the only thing I could possibly do is this. Are there factors of -2 that add to get to +3? Because the only ones I would say are -1 times 2 or -2 times 1. Do either of those add together to get 3? No. So there's no GCF. This is a hard type, so follow the flow chart. There's no GCF. Follow it down. Okay, this is a hard type. Can I factor it by this hard type method? So that's when we can write prime. If there's nothing done to it, not even a GCF, that's when we write prime.
Are you on the test going to make us rewrite the flow chart?
No.
Oh.
No.
I don't know what the flow chart is.
I'm going to post a video. Just watch out. There's some weird stuff in the video. Were you in here for that whole discussion?
I heard something about the history of math.
Yeah. Okay, I'm going to end the video now so we don't get too far off topic again. And then I'll show the homework for tonight as well.